This is graphing and solving quadratic inequalities. Let's get started. So the two essential questions we want to answer are, how do you graph a quadratic inequality? So the first thing we're going to do is graph one. And then what does it mean to solve the inequality, and how do we do that? So those are the two things I want you to be able to answer by the end of the notes. Okay, so the first thing we want to do is just graph the parabola, basically. So we're going to take this and we're going to graph it. Now you know how to find the vertex. We've done it before, so I'm not going to go over that here. But your vertex is 1, -4. So we can go ahead and plot that here. And then we've learned how to move with the pattern, right? So we're going to, in this case, since our A is 1, we're going to go up 1 over 1, up 3 over 1, up 5 over 1. So you've got to be able to graph it first. Okay, so that's all we did, graph the parabola, just like we've already learned how to do. Okay, then you want to pay attention to whether you have a dashed or a solid line. In this case, we have a dashed line, right, because it's greater than, it doesn't have an equal to, so it has to be dashed. So you just draw your dashed line, or your dotted line. The next thing you want to do is shade. Okay, the way that we shade here is we want to use a test point. So I'm going to use 0, 0 as my test point. It's the easiest. All right, so if I plug in 0 for x and 0 for y, so that would be a point somewhere in here. Okay, I want to know if this statement's true. So if my y becomes 0, it's greater than x squared, so 0 squared, minus 2 times 0, which is 0, minus 3. So all I did was plug in 0, 0 for x and y. So is 0 greater than -3? It is. Okay, so that's true. So that means that 0, 0 point, that means it is in the shaded area. So that means I'll want to shade it in here. Okay, if it was not true, if your statement ends up not true, then you don't shade where the origin is. You shade on the other side. Okay, so this is graphing a quadratic inequality. Graph the parabola the way we already learned. Make sure you use a dashed or solid line, depending on your inequality sign. And then shade. And you shade using that test point 0, 0. If it's true, shade wherever the origin is. If it's not true, shade where the origin is not. So in this case, we want to solve this quadratic inequality. So what it's asking us when we're solving is to tell us the x values for which the graph lies, in this case, below the x-axis. So I'm going to write that out here. It may take me a minute. But I want you to understand what it's asking you. So identify the x values, that's values, for which the graph lies, and in this case below because it's less than, lies below the x-axis. Okay, in this case it's below because it's less than. If it's greater than, we want to know where they lie above. And since it's not equal to, in this example, we don't want to know where they lie on the x-axis, only below. So less than 0, less than my x-axis. This is what it means to solve a quadratic inequality. So in order to do that, you're going to want to graph, okay, because we need the x-intercepts. So as of right now, we haven't gone over how else to find the x-intercepts. So as we find it algebraically, you wouldn't have to graph it per se, but we do need to find those x-intercepts. So I know that this vertex is at 3, -4 because of the way that we've learned it already. Okay, I'm going to move with my pattern. My A is 1. So I'm going up 1 over 1, up 3 over 1. And that's really all we need because we want the y-intercepts, but I'll go ahead and go up 5. All right, so here is my parabola. So my x-intercepts are 1 and 5. All right, so that's what we want to look at. So we want to know, identify the x value, so where our graph, where's the parabola less than 0? Okay, here's my x-axis, my 0. So where's the parabola less than 0? Well, right here, right? Because this part of your parabola is greater than 0. Only this part of your graph is less than 0. So that means from 1 to 5, on my x-axis, from 1 to 5, my graph will be below the x-axis. So that's what you would write. That's your solutions. So from 1 is less than x, which is less than 5. Or you could write it from 1 to 5. Now remember the parentheses, because they're not equal to, because it's that dashed line. It's not equal to. So this is solving a quadratic inequality. So let's go ahead and go to the next slide, and we'll try one more example together. All right, so I'm going to use the same quadratic as before, but now we're doing greater than or equal to 0 instead of that less than 0. So remember what this means is we want to identify the x values, so which values of x, for which the graph, okay, so for which my parabola, which the graph lies on and above the x-axis. Okay, so the same thing we talked about before, except in this case it's on or above because it's greater than or equal to. So where is it on the x-axis, and also where is it greater than, where is it above the x-axis? So again, the first thing you want to do is graph. And we already know from before where the vertex is at 3, -4. We already found that our roots were at 1 and 5, so I'm just going to go from there. And so there's my parabola. So in this case, we want to know where it's greater than or equal to that x-axis, or on or above the x-axis, right? So here is where my graph exists above the x-axis. So it's not in between anymore. It's on the outside, because this is going to go out and out and out and out forever and eventually make it over here. Same thing here. So in this case, we have a very different answer. So my graph is above the x-axis, on or above the x-axis, from -infinity until I get to 1. And it's a bracket because it's equal to. It's actually going to be included. And then nothing here. It skips here because this is where my graph is below the x-axis. So it starts again at this next root, which in this case is 5. 5 to infinity. So all of these x values are where my graph would exist above the x-axis. That's what we're looking for. So the x values that I can plug in here that would make this greater than 0 are any of these numbers. Anything from -infinity to 1 and anything from 5 to infinity. All right, don't forget to write your summary and your questions. I know that topic was a little tricky. It's probably the trickiest topic in quadratics that we do. So if you need to go back and watch it, go ahead and do so. If you have more questions that we need to answer in class, don't forget to write those down in your notes. That's it. Thanks for watching, and see you soon.